Welcome to the video lecture for section 2.3. This is for MAC 1105. My name is Jorge Gavin Young, and we're going to talk about lines. We're going to talk about slope, and we're also going to talk about parallel and perpendicular lines. I'm going to spend a little bit more time on some of these objectives and less time on some of them. So the first one is calculate and interpret the slope of a line. And so just a quick review, slope of a line is just the rise over run. The formula for a slope of a line is m is equal to y2 minus y1 over x2 minus x1, where x1 does not equal x2. If x1 is equal to x2, then L is a vertical line and the slope is undefined. So here are the four possible slopes. We get a slope of 0, which is L3, and that means simply that y1 is equal to y2. L4 is the vertical line, is undefined. Then that means that simply that x1 is equal to x2. M1 is a positive slope, goes up from left to right, and L2 is a negative slope, goes down from left to right. So if we get 2 points, 1, 2, and 5, negative 3, the first thing we do is label them. We can label 1, 2 as x1, y1, and 5, negative 3 as x2, y2, and then substitute it into the formula. Or we can label 5, negative 3 as x1, y1, and 1, 2 as x2, y2, and we still get the same value. So the slope is simply the average rate of change of y with respect to x, and in this case it's negative 5 over 4. That means that for every 4 unit change in x, y will change by negative 5 units. So this is just goes to the image, the first one about the four possibilities for slope. And then, so the next one, we're going to graph lines given a point and the slope. So if we get the point 3, 2, we're going to go ahead and graph it with the two slopes, 3 over 4 and negative 4 over 5. So the first one, slope 3 over 4, means that for every horizontal movement of 4 units to the right, there will be a vertical movement of 3 units. So if we start at 3, 2, we move 4 units to the right and 3 units up, we'll arrive at 7, 5. Then we can just draw a line through the 2 points. For the next one, negative 4 over 5, means that for every horizontal movement of 5 units to the right, there will be a corresponding vertical movement of negative 4 units. So if we start at 3, 2 and move 5 units to the right and 4 units down, we'll end up at 8, negative 2. We also could have done 5 units to the left and then 4 units up, and then we would have arrived at negative 2, 6, which is also on the graph. So here's the first one. So we start at 3, 2. We go up 3 and over 4, or over 4 and up 3. We arrive at 7, 5. And then this one, 3, 2. This is where we go over 5 and then down negative 4 to arrive at 8, negative 2. Or we go to the left 5 and up 4 to arrive at negative 2, 6. And you see they're all points on the same line. So we're going to find the equation of a vertical line. So if we graph x is equal to 3, that simply means that the equation of a vertical line is x is equal to 3, where a is a real number. And so if you were to graph this, what you would do is simply put a vertical line where x is equal to 3, and then pick some arbitrary points for your y. The next one, we're going to use the point slope form of a line. We're going to also identify horizontal lines. So the point slope form of the equation of a line is y minus y1 is equal to m times x minus x1, where m is the slope and the point x1 is in the line or on the line. So here we got again x1, y1, and xy. So when we use the point slope of a form, so an equation of a line with slope 4 that contains the point 1, 2 can be found by using the point slope form with m is equal to 4, x1 is equal to 1, and y1 is equal to 2. So we substitute those values into the formula. And then at this point in time, we go ahead and do distributive property on the second line. So we end up with 4x minus 4. And then we add 2 to both sides. And then finally, we end up with 4x minus 2. And then this is the graph of that equation. Now, the equation of a horizontal line is in the form of y is equal to b, where b is a real number. And so find the equation of a horizontal line containing the point 3, 2. So the nice thing here is we use the point slope form, and you can see that the slope is 0, so we end up with y is equal to 2. And so this is simply a horizontal line that goes through y is equal to 2. Okay, find the equation of a line given 2 points. So if we have 2 points, we're going to find the equation of a line. The first thing we're going to do is we're going to find the slope of the line. The slope that we found given these 2 points is negative 1/3. And then we're going to use that information with the point slope form and plug that into it, and we get y minus 3 is equal to negative 1/3 times x minus 2. I would do it a different way, and I'll show that in class. And then we can go ahead and graph this equation. Next thing is write the equation of a line in slope-intercept form, and this is my preferred way of writing it. I don't like to use the point slope. An equation of a line with the slope m and the y-intercept b is y is equal to mx plus b, where m is the slope and b is the y-intercept. And so we're going to identify the slope and y-intercept of a line from its equation. Again, in class I will show some examples of how we can, instead of using the point slope, we can use the slope-intercept form. So finding the slope and the y-intercept. So we're going to find the slope m and y-intercept of the equation. 3x plus 6y is equal to 12. We're going to graph the equation. So in this case, what we do is we write it in slope-intercept form. So we solve for y. So we subtract 3x from both sides, and then we divide by 6, and we end up with negative 1/2 x plus 2. And in this case, the slope ends up being negative 1/2, and the y-intercept is 2. And we can actually go ahead and graph that. I will also show in class a way of how to find the slope if it's in standard form without having to solve for y. So we're going to graph lines written in general form. In general form is ax plus by is equal to c, where a, b, and c are real numbers and a, b are not both 0. And so here we have 2x plus 4y is equal to 8. We're going to go ahead and graph it by finding its intercepts. And so just a quick review from one of the earlier lectures, we find the x-intercept, we let y equal to 0, we solve for x. In this case, we get x is equal to 4. And then to find the y-intercept, we set x equal to 0 and solve for y, we get y is equal to 2. And so now we can plot the 2 points, 4, 0, and 0, 2, to draw the line through the points and graph the equation 2x plus 4y is equal to 8. Next thing is find equations of parallel lines. And then so parallel lines, they have the same slope, as you can see here by this image. So criteria for parallel lines: two non-vertical lines are parallel if and only if their slopes are equal and they have different y-intercepts. So here's L1 and L2. You can see that they have exactly the same slope, but they have different y-intercepts. So finding a line that is parallel to a given line. Find the equation of a line that contains the point 2, negative 3, and is parallel to 2x plus y is equal to 6. So the first thing that we do is we solve the original equation for y, slope-intercept form. We get negative 2x plus 6, so the slope is negative 2. Since the line that we're looking for is parallel, we're going to use the same slope. So we're going to find the equation of a line with a slope of negative 2 that contains the point 2, negative 3. In this example, they use point slope. I'm going to show you in class how to use the slope-intercept form to get the equation. So here we plug in the values of m, x1, and y1. We solve for y, and we get y is equal to negative 2x plus 1. So parallel lines. The original line was y is equal to negative 2x plus 6. This one is equal to negative 2x plus 1. Same slope, different y-intercepts. And then we write it in general form, which simply means adding 2x to both sides. So the line is parallel to the line 2x plus y is equal to 6 and contains the point 2, negative 3. And here's the graph of both lines. Next thing is find equations of perpendicular lines. So perpendicular lines intersect and they form a 90-degree angle. The other thing is for two non-vertical lines are perpendicular if and only if the product of their slope is negative 1. So if two non-vertical lines are perpendicular, that means that the product of their slopes is negative 1. In other words, they're opposite reciprocals. So find the equation of a line that contains the point 1, negative 2 and is perpendicular to x plus 3y is equal to 6. We're going to go ahead and graph both lines. So the first thing is we solve what they give us for y. We get y is equal to negative 1/3 x plus 2, which means the slope is negative 1/3. Again, there's a different way of finding the slope, and I'll talk about this in class. So any line that is perpendicular to this particular line has a slope of 3, which is the opposite reciprocal. Now, the point 1, negative 2 is on this line. With a slope of 3, we use the point slope form, and we get the equation that is y is equal to 3x minus 5, and in general form becomes 3x minus y is equal to 5. And in the graph of both lines. And that's the end of section 2.3. Thank you.